And we're going to just take a look at what's coming straight out of here. Okay. And okay. So on channel 2, this is my input signal. Okay. My input signal is looks like a negative cosine, or I'm sorry, a negative sign. Can you guys see that? Would you prefer it to look like a sign? There we go, now it's a sign. All right. So that's a sign, just to make it a little easier to see. You guys can see that's a sine function? That's all right? Now, that's going into this coil. If I've got this function generator creating a current in this coil has a current going in this way. That's going to create a magnetic field going this way, which is going to be in this coil in the middle. This coil in the middle is going to have an induced current in it. Okay? That induced current should be related to the original current according to that expression we just wrote down, negative NA dB dt. Okay? Now, we're going to bring up that second one. There it is. And the first thing you notice is it appears to be smaller. Okay? Smaller. The second thing you notice is there's a difference in phase. And we'll put them both up there. This one is sine, and this one is what? Not negative sign. It is negative sign, isn't it? It's exactly inverted, right? Okay. So you guys can see that it's exactly inverted. And if I were to swap these two wires, now it's exactly the same. Okay. Let's make sure we're being consistent with the two terminals. So what that's telling us is we're producing a current here, we're inducing a current here. That induces some EMF in this coil, which then we measure with our oscilloscope. Okay. All right. And if I reverse, so these two terminals are measuring my original signal. And if I turn this over, you guys notice, first of all, is I take my coil and I rotate it through so that it's 90 degrees. Okay. You notice that my voltage went to what? Zero, basically, right? And that's because the magnetic field is going this way, and my plane of my loop is perpendicular to that. Okay. If I keep rotating, you notice that I get back to the full current. Now, is there any difference between the two orientations? Okay. So here it is with the coil facing down. Here it is with the coil facing up. And you notice they are... I'll do it again. High. So here that's up, that's down. Did you guys notice how it became opposite? Okay, and that makes sense based on just how it's really just like swapping the wires on the coil. Is that okay? All right. Now, if I take this, we'll rotate it back to the way we had it, and if I move it around in here, do we see appreciable changes as we move it around? Yes. Yeah, as I get it closer and closer to one edge, we're seeing a larger effect, right? I mean, there's a couple things going on. This is not an infinite coil; it's a finite coil, right? And if I just lift this up a little bit, because it's not an infinite coil, we don't have a completely uniform field in here, right? So we have a stronger field near the edge than we do at the center. Is that fair enough? We're going to model all of our coils as infinite to make the math easier. All right? Okay, so we can see this process of induction between our outer coil and our